Hello, my name is Mirsaid Abdullayev and I will be showing you a walkthrough of my entire project blockchain application. During this walkthrough, I'll be showing outputs from 3 different devices and I'll be cutting to and from the separate screens to show you the outputs at each stage during the operation of the blockchain. For reference, this current device screen will be the root node, so it will be the main node on the system, and the 2 subsequent nodes will be the branch node and the leaf node. I'll be showing how they're connecting together, and I'll also be showing how data will be flowing to and from each of the devices as well as their connections. To begin the walkthrough, I have first compiled a quick list of my walkthrough data, which will be the addresses of the 3 devices I will be using. Just for easier reference, they will be kept here so I can copy and paste in and out of the application when I need to. So for the first part, I will log in as a root node, which this device is configured as. So once I click connect and synchronize, a user is presented with a choice to be a mining node or not. In this case, I will type yes. Local synchronization then occurs, and we are now greeted with a main menu. As you can see, we can see the status of the node. So we are online and we are the root node. There's no wallets logged in and no balance currently. So we have all these options to explore. So firstly, I want to show the network status. So currently, as you can see, I'm a root. My IP address is 192.168.1.151. I'm online and no previous or next pointer devices have been configured, so I'm not connected to any. And we have a test chain of 50 blocks stored in RAM and in memory, in local storage, sorry. So we have all these blocks. You can see all the data is live and visible to the user. So block 49 has a hash of 0051 and ends in B7, and as you can see, the previous hash of block 50 is the same as the hash of block 49, showing the blockchain's linkage of block objects. So as you can see that we have 50 blocks in our test chain, which will be important to see on the subsequent devices that will connect. For them to connect successfully, they must also synchronize to 50 blocks. So now I will be showing how to log into a wallet and all the functionalities of wallet management. So if I take myself back to the main menu, if I go into wallet management, I will first log into an existing wallet, and as shown, this is the root wallet in my test data. So I'll need to enter the private key, which is this value here, and as you can see, all the steps are clearly labeled by the program. Enter private key to this wallet, or click cancel to exit. I can click cancel if I want to, and nothing will happen. So I'll log in now, and we can see I've got a balance of 50. That's my public address, which is correct, and the name. Once I click OK, the status label changes. I can also generate new wallets through this. So say I do test 2, and as you can see, generates me a private key. And then view wallets, that's all the wallets stored on my system, and I can delete a wallet like this. If I click back, the status label here updates as well. So that was the wallet functionality walkthrough. The next thing I will be showing quickly is the transaction pool. Same status label as the previous, and obviously it's empty right now, but the next video I am going to show you is from device 2, where we will connect to this node and we'll see the changes that will happen here, as well as on sending transactions between devices. I will be showing that as well. Okay, so cutting now to device 2, this is going to be the second device to connect to our already online root node. So we're expecting an online synchronization to take place once I click connect and synchronize. So my minor choice will be yes in this case. And as we can see, the background listener has started and it's already connected to the already live root node, and now the data is being transferred from the root node to this device, and as you can see, it's already completed synchronization. So just to confirm that, we go into the Blockchain Explorer, we go into the network status view, and as expected, the previous pointer to the previous device is 192.168.1.151, which was our root node. Our node type is leaf, no one else is connected to us yet, and our own address is ending in .98, and we're now online, which means that we're fully synchronized. So just to check that view, we go into the Blockchain Explorer, and again we're greeted with hopefully all 50 blocks as we expect, and as we can see, that is exactly what's happened. The hash is still correct, and the previous hash is also ending in B7, starting in 0051. So all the data is successfully transferred from the root node to our new leaf node, and the correct connections have been established. Now I'll test the wallet login. So if this is for device 2, so this device should read its own local storage to find correctly that device 2 wallet is stored in its local storage. So now we can log into device 2 with my pre-prepared data. So as we can see, we have a balance of 90 here, our public address which matches. Let's click OK, the status label changes, and we're now logged in. We're logged in, we're connected, and this showed how easy and simple it was through my blockchain to simply connect with an existing device within a matter of 20 seconds. And the next video will be testing the third device connecting to the network. So it will be connecting to this device, device 2, and we will be sending a transaction to device 2. So we are now on device 3, and this will run through the same way as we've done for device 2. So we click connect and synchronize, we'll make it a minor node, we'll start looking for online nodes, and note the time that it takes to find the synchronized node to synchronize with. Now it's transferring the data, as you can see by the status label, and just like that, in less than 15 seconds we already have a fully synchronized node. So if I go into the Blockchain Explorer, we can see in the full view that we are indeed on block 50, and it's the same data as all the previous nodes. And if we go into the network status view, we're now connected to the old device 2, which was the leaf. Now we are the leaf, and our own IP address is .214, and there's obviously no one else connected to us, so we've correctly synchronized. Now we'll log into our device 3 wallet test, and I will be conducting a test transaction sending to device 2. So if I log into our device 3 wallet, we can see our balance is 125 credits. So now that updates. If we go back to our menu, we we want to go into send cryptocurrency view. So we want to enter the public address of the node that we want to send data to, cryptocurrency to. So we pick device 2, and it's the public address. So we enter that. So it transfers the address into this box. If we enter the amount, I'll be sending 25 tokens worth of cryptocurrency. So now we've filled in the data, we can check the details and send to the transaction pool. So we get a message giving us all the warnings. This is your final chance to check any incorrect details. We can click cancel still to cancel the transaction. Our sending amount is 23.75 after deduction of a 5% fee for the future miner of this block, and it will be 1.25 tokens, and our recipient address is correctly transferred. Now we click OK. So the transaction has been sent to the outbound buffer. We can see it's in the pending transactions, and soon enough it's already been approved and our balance has decreased by 25. So now when we go back to the menu and we go to view live transaction pool, we can see the transaction has already been approved and is already on the transaction pool view. So that's how a transaction is sent, and in the next video I will pan back to device 1, which is the root, and I'll send the second transaction and show how mining works. So we are back to the device 1, which is our root, and we'll show the live transaction pool with the old transaction sent from device 3 to device 2. You can verify the addresses on the left here. That's the ones that were shown in a previous cutout. So now we will be sending another transaction, but now we'll be sending from our node 1, which is the root, and we'll be sending to device 3. So to do that, as we already logged in, we go straight to the send cryptocurrency wallet. We click here to enter the address. We'll enter device 3's public address. Click OK. It's correctly pasted into the text box, and we will send some value 27.2 as our test amount to send. Click OK, that's correctly transferred. We check our details. So as again, it splits into 5% fee, which means that we'll be sending away 25.84 will go to device 3 and 1.36 will go to whoever mines this block, and the mining will happen immediately after this transaction is processed, as I've altered the max transaction size to 2 so that we can see the mining in action. So once I click OK, transaction has been successfully sent to the outbound buffer, and it's here in the pending transactions, and now it's been processed. Our balance has been changed, the mining has begun in the background, and now as you can see the status updates to unable to currently send transaction as we're in the mining sequence, and all we have to do is wait as the mining is now complete and we are actually the miner, so the fees will be claimed and the balance will be updated. So as you can see now, the balance has changed to 25.41, which is our old 22.8 plus the 2 other fees, which were 1.25 and 1.36. And now to test and see the new block that was mined, we can go here and we can see block 51 was mined on this timestamp. We can see our transactions and the miner field here, which is, as you can see, our public address. So that wraps up my testing video and walkthrough for my program. Before I wrap up, however, I'll also show a quick view of device 2 and device 3 having updated their own blockchain explorer. So looking at the output for device 2, we can see that the balance has changed now from 90 to 113.75, which is an increase in plus 23.75 tokens, which is correct considering that device 3 sent us 25 tokens, of which 1.25 were taken as the miner fee, so we have received our correct 23.75 tokens. If we check the blockchain explorer now, we can see that the block 51 has been successfully added as well and validated. The miner is the root node and 2 transactions as we expected. And going to the transaction pool, we can see that both transactions that were waiting to be confirmed are now fully confirmed on the blockchain as seen in the block explorer. So this wraps up device 2's output videos. So for the final device output, we're logged in as the leaf node of device 3. As we can see, the balance is updated from 125 to 125.84 as we have sent out 25 tokens to device 2 but received 25.84 tokens from device 1. Again, as with the previous device 2, I'll show the blockchain explorer on the correct block 51 with the same hash, the same previous hash, the miner node as well being root wallet, and the 2 transactions being the same. Balance is obviously 125.84, and the transaction pool again is empty, and that wraps up the entirety of my project blockchain walkthrough, where we have shown how we send cryptocurrency, how cryptocurrency is received, how blocks are mined, and the user interface and how a typical user would be using this application.